Hello everyone, welcome to today's webinar about using graph analytics for entity resolution. In today's session, I will be joined by Shrey Ilianga. Introduce yourself.
Hi everyone. First of all, thank you for joining in, taking some time off. My name is Shrey. I've been with SoftLink for about 5 years now. We've established an analytics center in the Netherlands, and I head that division. I basically deal with graph analytics and deep diving into customer issues to solve their problems through finding links between connected data. I've majored in machine learning and artificial intelligence. Analytics, I would say, it hopefully is my forte.
Thanks. I'm very pleased to have you on board to bring your expertise to this complex topic. As for myself, my name is Jean Villedieu. I'm one of the co-founders of Linkurious, where I'm in charge of everything related to the go-to-market, such as sales, marketing, and partners. So here is a quick rundown of today's agenda. So we are going to start with discussing what is entity resolution. Then we will talk about why entity resolution is so important. After that, we will dive into why graph analytics is well suited for entity resolution. And finally, to give some meat to all of this discussion, we'll do a demo and talk a bit about a use case. So this is the agenda of today's session. So let's get started and let's talk about what is entity resolution. So entity resolution is the process used to figure out whether records from one or multiple data sources represent the same entity. So whatever organization you are working with, whatever job you have, the relevant data that you need to make decisions is probably scattered across different systems. Linkurious Enterprise can help you visualize and analyze the complex connections within your data, such as relationships between people, locations, phone numbers, IP addresses, and more. But how to create an holistic picture of these entities and the relationships when the information that you have about a given client, such as John Doe, exists in 3 or 4 different systems. So that's where entity resolution comes into play. Entity resolution, once again, consists in determining whether multiple records from multiple systems represent the same entity. And technology can help do this at scale, but of course, that process is always going to be imperfect. And no matter how much data you have or how smart your algorithms are, there may be an ambiguity about whether 2 John Does are the same person or not. So that's for a quick introduction to what is entity resolution. Now I would like to discuss why it's so important. And I'm going here to focus on a specific context, the context related to financial crime. In financial crime, for example, there can be multiple reasons to leverage entity resolution to get more value out of your data. So one such example is that you may want to complement internal data that you have about clients with corporate data sources, such as Dun & Bradstreet or Bureau van Dijk. If you want to do that, then you need to understand that your client X is actually the same client X with reference in the Dun & Bradstreet database. And that's not a trivial issue. Another reason is that your organization may have data about a given client in multiple internal systems. So here it's not about merging your data with data from the outside world. It's really about merging together data from within your own organization. And if you don't do that, then there's a big risk of missing clues when you are doing investigations or incorrectly assessing the riskiness of a given client. And finally, you may be dealing with rings of criminals that create fake identities with variations around a few names and addresses. And once again, entity resolution can help detect this sort of problem. So here you have three concrete examples of why entity resolution can help. So how to deal with information scattered across different data sources, and how graph analytics can help with that problem. So let's start with a very small scale example. Here we are dealing with 3 different systems, 3 different records, and we can see on the top left corner that we have data in an insurance database, and it relates to a client called John Smith. It has that client has an email address and a phone number, and we see, in other systems, other John Smiths that may or may not be related to the first one. And what's essential to understand whether we are dealing with the same person or not is to actually understand the connections that are hidden in this data. And here, very simply, very visually, we can figure out that there are indeed some connections. That first John Smith seems to be sharing a phone number, an email address, I guess, with the one in the retail banking database, which itself has the exact same full name as the one in an external company registry. So it's really small scale, obviously, but figuring out the connections across these 3 distinct records is helping understand whether or not they're indeed the same person. And here it appears that they are. Now the challenge really is to do it at scale. How to conduct the same type of analysis across tens of millions or more data points, and how to do that in real time. So that's where graph analytics and Linkurious Enterprise come into play. So here is an example of how to apply graph analytics for entity resolution. So we see data coming from various sources, such as internal databases with KYC information, or databases with information about transactions. There can also be external data about politically exposed persons or company ownership. The first step is really to import this data into a graph. At this step, each entity is turned into a node connected to other entities via relationships. For example, a given client can be connected to its phone number. And just based on that information, there may already be indirect connections between entities, such as 2 clients sharing the same phone number. The next step involves analyzing these connections between entities to identify similar entities. And here we can apply simple business rules. For example, 2 clients sharing the same ID number can be considered as similar. We can also decide that 2 clients sharing both a name, an address, and a phone number should also be considered as similar. After that, we can look at the groups of similar entities to identify communities. These communities of similar entities can then be resolved or turned into a single entity called a golden record. And finally, all of this information, it can be made accessible to analysts via the Linkurious Enterprise UI. So here is really a high-level overview of how to leverage graph analytics for entity resolution.
Thank you so much, Jean, for that lovely explanation. So before we get into the demo, we will be sharing some of the aspects of the case study that we did for one of our customers, having to contend with some data, as you can see. The figures expressed here indicate that the entity resolution systems have a bit of data to work with. So you can see about 1.1 billion nodes, 4.2 billion relationships. So this is a large set of data. And the point of entity resolution is that it's always in a continuous integration, continuous development mode. So we call that CI/CD mode, which means that there will always be data coming in, and there'll always have to be, these entities will have to be resolved in real time. So because of that, our system has to be completely automated and should be able to resolve these entities in near to real time. So let's get into the demo without any further ado. we identified two types of users basically who would be using Linkurious Enterprise. The first type of user would be the end user or the business user, where they would be consuming the information created and managed by the entity resolution system. The second type of user would be the power user who will have full access to the system and its data and will be able to develop and modify the system and its contents. So the power user will be the one who will be modifying the rules of entity resolution as and when they evolve and change. So as far as the business user is concerned, everything will happen automatically. He will not see the nitty gritties of how the entities are getting resolved, but he will just see, or they will just see the entities that are resolved and their subsequent golden records that are created. So let's get into how the data is populated and modeled in the graph. So if I was to open this visualization in Linkurious Enterprise, you will see two entities that are visible here. This first entity is Jas, and the other entity is A George. So if I was to expand all the neighbors of this entity Jas, you will see that, well, he has an email. He has a PIN code because he stays at an address. There is a social security number attached to it. He owns a mobile number, and he stays in a particular city. Now, there could be a possibility that these personal identifiers, as we call them, are being shared with another entity or another individual. So let me expand on the social security, and then it'll be visible that Mr. Jazz has been sharing his social security, PIN code, mobile number, and city with another entity called Girpesh. So because his social security is being shared with another entity, it is highly likely that these two individuals correspond to the same entity, because social security number is sacrosanct for an individual. It is unique for a particular person, and if that number is being shared with two entities in two different databases, then for sure these two entities belong to the same person. And it's also the same thing with the phone number and the address. Now you might say that, okay, as far as the address is concerned, well, he could have roommates, he could have his partners living with him. However, if a person shares an address, an email, and a mobile number with the same person, so in this case, you can see this entity is sharing the mobile number, the address, and the email with our original entity, this one. It is very clear that these two people are the same. I mean, if we were to imagine a real world scenario, many people can live in your house, but it is very rare that two different people will have the same phone number, email, and address. So for the sake of this demo, we have taken three main rules for resolving these entities. The first rule is if two people share the social security number, that means that they are the same entity. The second rule is if they share the same phone number, the same address, and the same email, that means that they are the same entity. And the third rule is if they have similar sounding names and they share their phone number and address, then again, they are the same entity. So let us see how this entity resolution will look for the business user. So if I was to go back, so Linkurious Enterprise has a really beautiful feature called alerts. And through these alerts, we can run these queries automatically onto the database that will create these links directly between these two entities. So let me enable these alerts and go back to my visualization. So you see right now, these two entities, this one and this one, have no direct links between them. They are linked, however, through their personal identifiers like the social security number, like address, phone number, and email. However, to resolve these entities and resolve them into clusters, we need to create these direct links between them. So how do we do that? Well, automatically, our alerts will run these queries that will link these two entities directly based on the information that is being shared. So if I was to go back to the alerts column, you can see that our alert has run now. And we can see all the links that have been created between these entities. So as we saw earlier, Mr. Jas and Mr. Girpesh are now linked together, as we can see in this visualization. So if I was to expand on the social security number, you will see that now these two entities have been linked directly with a relationship called has shared attributes. This was the similarity relationship that Jean was mentioning earlier, that we need to connect entities together based on some similarities. So this has shared attribute now has a score of 1 because the social security number has to be an exact match. So let me go back to my match list. Let me go back to my alerts again. Okay. Now we apply the second rule, which is creating this direct link between these entities based on email, phone number, and address. So over here, we only have one entity that satisfies this rule. And again, you can see that if I was to expand on email, phone number, and address, you will see that these two entities were sharing all these three personal identifiers, and hence a direct link between them has been created. Well, what is the next step? The next step is to cluster these entities that have this relationship between them called has shared identifiers. Once we cluster them, we will be able to form a sacrosanct golden record, which will represent the same entity in one particular cluster. So let me go back to my alerts again. And you can see that this alert, which will resolve the cluster IDs for a particular entity, has been run. So you can see these two entities now belong to the same cluster ID. Two more entities, Aditi George and Aditi G, are also belonging to the same cluster, and so on and so forth with the rest of the data. You can see that this last entity belongs, let me go back. This last entity belongs to the same cluster ID 0 as the first two entities. So the first two and the last one are in the same cluster and hence are the same kind of entity. The next one, the next step would be to run our golden record alert. This golden record alert, what it will do is create a set of golden records that will link all the entities that belong to the same cluster. So now we will wait for this particular alert to run. It will run every 5 minutes. So because these alerts will run every 5 minutes or based on whatever frequency we want them to run. So if I could show you over here, we can see that we can change the periodicity of every alert that we have to run. So depending on what situation we have in a particular organization, whether the entities have to be resolved in near real time, so then we would run the alert every 5 minutes, or whether the entities can be resolved per day or per week or per hour. Depending on that frequency, we can schedule these alerts to run so that the incoming data that is ingested into the graph is continuously resolved. And hence, we comply with the continuous integration, continuous development mode, the CI/CD mode. Let's go back to our original alert and let's check if that has run. Yep, we can see that the golden records have now been created. Let me go here. Let me just click on this one. So you can see this entity is belonging to this particular golden record, which also has two other entities on it. So now it is very clear that a golden record comprises of the same, of all the individuals that represent the same entity. Now, you might ask me, well, what attributes can a golden record have? So the golden record will only contain the attributes which are 100% common for all the three entities. So something like your social security number, or maybe like a passport number, or even an account number. However, an account number can be different for different individuals. So let's go back. So this is what the end user will see. So if I go back to my visualization now and I get rid of all these things that are here, and I just run a query of get me all the golden records that exist in my database. You can see that this query has given me all the different golden records that exist. So now if I was to expand the entities of this golden record, well, you can see that this golden record contains 2 individuals. This one contains about 3. This we already saw, and so on and so forth with the others. So in the end, we will only be concerned with this particular golden node called the golden record, because this contains the cluster of all the resolved entities. And now for the business user, this has happened completely automatically, where there is no need to dive into the nitty-gritties of how these queries are being run, what rules are being applied. The business user need not be concerned by any of them. Let's go to the other type of user that will be using Linkurious Enterprise, that is the power user. Well, for the power user can now design these queries subsequently. So let me dive into what these queries are doing. So we have the first query here that will create the shared attribute relationship between entities based on their social security number. So I could show you this query. This is a very relatively simple query where if 2 entities are sharing the same social security number, there will be a relationship created directly between them called hash shared attribute, and it will store the social security number as its attribute, and the score will be the average of the score between the relationship onto that social security node. And that way we can actually score these strengths of these relationships. So further on, if we have to value whether these entities are linked together strongly or weakly, the score will come in handy. The next step is to apply the second rule that we have, is create the shared attribute on the address, phone number, and email. So a power user will be able to go and create these queries in the editor, save them, and then view them from this panel called the query templates. The third rule was to create a shared attribute relationships between the address, name, and email, if all those 3 match together. The name obviously will be a fuzzy match, and you can use different text similarity distances to match the names in a fuzzy way. The next step, as Jean explained in the slides, was to create clusters of these entities that are having this shared attribute relationship. So the cluster creation runs a particular algorithm from Neo4j called the weakly connected components algorithm. So what the weakly connected components algorithm does is basically, if 2 entities can be reached to each other from a different node, these entities are considered weakly connected. So for example, if A is connected to B and B is connected to C, we can consider that A and C are weakly connected entities. So we can actually run graph data science algorithms on Linkurious Enterprise and cluster these entities together, which have this particular relationship between them. So the power user is now able to modify all these parameters that have been created, and he can then modify these parameters as the rules change with your organization. So for example, we've been taking address, phone number, and email as a rule to connect entities. Now you may say, okay, maybe a year later, this rule does not apply anymore, and we have 3-4 more rules that take place. So the power user can now create these new queries based on these rules, apply them, and then run the same particular clustered algorithm without any change. Well, after this weakly connected components algorithm has run, next we will create the golden records. And then based on those golden records, we can now visualize these golden records that have been created. Okay, so we've covered the fact that we have resolved all the entities that exist in our database, but one part is still missing. And that is very sacrosanct to the CI/CD mode that the entity resolution system must work in. What about the new data that comes in? Well, let us take that example. So let us consider our first entity that we saw earlier, Mr. Jazz. Okay, we would like to expand all his neighbors, including the social security number. So let us just take social security number for now. Well, what if a new node comes into the database? Now, normally this process is automated, but for the sake of this demo, I have to create this node manually. So let me create a new node with a label called entity. And as you can see in Linkurious Enterprise, creating a new node is so easy. It's just without any code, we can assign a label to it, and then all the properties that are represented from the label just come into play. So now I will give this node the name of Shrey. So you can say Shrey is the new node that will be created, and a new SSN. Shrey has the same social security number as that of Jazz. So I will save this node now, and now create a relationship between Shrey and social security. So let me create the relationship between Shrey and the SSN. So for now, Shrey does not have a relationship between Jas and Shrey. There is no direct relationship that exists. Well, let us go back to our alerts and let me expand this golden record also to show you. So technically now, Shrey should belong to the same golden record as Jas does because of our entity resolution rules. So let us go back to our dashboard and let us go back to the alerts. So we will wait for the alert to run, is create the shared identifiers relationship based on the social security number. So the alert will run, because I've scheduled the alert to run every 5 minutes, the alert should run in about 2 minutes from now, and then create this relationship automatically between Jas and Shrey. So if I was to go back to my visualization, I can see for now, Shrey does not have a relationship between Jas and himself. You can see that Jazz's cluster ID is 0, and all the entities in the golden record have the same cluster ID. So this entity has the same cluster ID of 0. This entity has the same cluster ID of 0. So as soon as our alert is run, in about a minute, you will see that Shrey will now be resolved to that same golden record that had the earlier 3 entities. And this will comply and with the CI/CD mode that we had mentioned earlier, is so that the new data that is continuously ingested is continuously resolved in near to real time. So I think the alert should have run by now. Yep, we can see that the new alert has run. Let me open it. And you can see now that automatically there is a shared attribute relationship created between Shrey and Jazz. And obviously, if I was to expand Shrey again, you can see that the same relationship has been created with another individual because they also share the same social security number. Okay, now let's go back to my match list. Let's go back to my alert. Let's go back to the golden record. Okay, so similarly, from this demo, it is obvious that Linkurious Enterprise can help create entities and resolve them in real time. Linkurious Enterprise also is able to comply with the continuous integration, continuous development mode, which is entities as they are being ingested are resolved in near to real time. Linkurious Enterprise also is able to house 2 different types of users. One is the power user, which is basically the user who will create and modify these queries as and when these rules change. The second type of user is the business user or the end user who will only see these relationships being created automatically. And to him, everything is kind of in terms of a magic where these golden records are being formed out of thin air and these entities are just being resolved automatically, which is what a good entity resolution system should be able to do. So this is it from the demo. Jean, over to you.
Thank you so much. Great demo. I'm going back to the presentation now. So thanks for this very practical, very concrete demonstration of how to apply graph analytics and Linkurious Enterprise for entity resolution purposes. In the demo, we have seen various ways Linkurious Enterprise can help investigation teams with entity resolution changes. First, the connections between various records identified via the entity resolution process can be displayed to the analyst. We can use sizes, colors to help identify the level of confidence regarding whether multiple records represent the same entity. This way, we really present this information to the actual end users, and this can help open the black box of the entity resolution process. At the end of the day, it can help analysts make more informed decisions. Linkurious Enterprise's alert system can also help detect potential duplicates, execute rules, and showcase the results to the analysts. And with access to the results of the entity resolution process, the analysts can then confirm or dismiss the results. This is a very concrete and practical way of combining algorithmic intelligence and human intelligence in the same entity resolution process. And finally, via Linkurious Enterprise, the analyst can delete or merge entities. So they can also actually manually curate the data to ensure that it is of a high quality. So these are some of the ways Linkurious Enterprise can facilitate the entity resolution process. Okay, so we have seen a demo, and in today's presentation, we have shared how to combine Linkurious Enterprise and graph analytics to perform entity resolution. If you want to go further, there are really multiple ways to improve your own entity resolution process. First, it's possible to leverage machine learning to identify potential similarities between records. And this can be used as an input to create the graph. So the machine learning approach can identify similarities that can then be leveraged by the graph algorithms. So that's one first way to enrich what we have displayed today. It's also possible to look for more complex links between entities than the one that we demonstrated. In the demo, we have seen two persons that can be connected to the same address if they share the exact same address, for example. The addresses can be normalized to facilitate this process and to avoid a misspelled address turning into an unidentified connection between two individuals, which can be something that happens in a real life scenario. Similarly, we can also look beyond exact addresses and focus on geographical proximity, so just considering that two persons are similar if they live in the same street. So that's some examples of options that you can do in terms of tweaking how to identify links, and obviously there are some trade-offs here in terms of noise versus signal that's generated by these approaches. One other way to really go beyond what we have demonstrated is to use the graph inputs via node embeddings in a machine learning platform to use machine learning for link prediction. What I want to stress here is that this demo that we have shared and this presentation is really a way to get started with applying graph analytics for entity resolution processes, but you can go beyond that. So that's it for today's presentation. If you have any questions, feel free to ask them in the chat section once again. And if not, we are going to start answering some of the questions that have been asked.